Think about the most advanced machine in your home. The one with the most precise gears, the tightest tolerances, the most impossible engineering. Now imagine someone found that machine buried in a layer of rock from 3,000 years ago. That's not the plot of a science fiction novel. That is the actual dilemma archaeologists face when they pull certain objects out of the dust. Because every few decades, we dig up something that should not exist. An object so precisely engineered, so logically advanced, that it looks less like an ancient artifact and more like something dropped by a time traveler. This is the paradox that keeps engineers awake at night. And in this documentary, we are going to show you 7 ancient objects that seem designed by modern engineers. By the time we are done, you may never look at history the same way again. The story of human progress is supposed to be linear. Stone, bronze, iron, steam, electricity. Each era building clumsily on the last. But scattered across museums and excavation sites are 7 anomalies that break this timeline entirely. Objects that display tolerances measured in thousandths of an inch. Devices that rely on scientific principles not officially discovered for over 1,000 years. Structures that modern construction companies cannot replicate without digital tools. We are not talking about mysterious rituals or spiritual symbols. We are talking about hard, measurable, repeatable engineering. From a 2,000-year-old computer to concrete that outlasts our own. From invisible lenses to earthquake-proof columns. These are the 7 artifacts that force us to ask one uncomfortable question. Did our ancestors know far more than we have ever given them credit for? Let us begin with the object that started everything. In the year 1900, a Greek sponge diver named Elias Stadiatos descended into the stormy waters off the island of Antikythera. He was looking for sea sponges. What he found instead would rewrite the history of technology. 43 meters below the surface, Stadiatos discovered a shipwreck filled with bronze and marble statues. But among the art, there was a corroded lump the size of a large book. For months, no one paid attention. Then the lump cracked open. Inside, archaeologists saw something impossible. Intricate bronze gears, layers of precision wheels, inscriptions in tiny Greek text. The object was eventually named the Antikythera mechanism, and when modern scientists X-rayed it, they nearly fell out of their chairs. The device contained at least 30 separate bronze gears arranged in a complex differential system. The teeth on these gears were cut with an accuracy of 0.5 millimeter. That is finer than the thickness of a credit card. Here is the engineering insight. The Antikythera mechanism is a mechanical computer. You turn a crank on the side. That motion drives a series of gears that calculate the position of the sun, the moon, and the 5 known planets. It tracks the irregular orbit of the moon using a pin and slot mechanism that modern engineers call a genius solution to a non-linear problem. It even predicts eclipses down to the exact hour. But here is the impossibility factor. This device dates to 100 BCE. The next time anyone in history built a mechanical calculator with similar complexity was the 14th century. That is a gap of 1,400 years. Even today, machinists struggle to cut gears that precisely by hand. So how did a Greek craftsman, working with hand tools and no computers, design a device that required knowledge of planetary motion, differential gearing, and precision metalworking? The question is not what the mechanism did. The question is how they thought of it at all. And the most terrifying part? Ancient texts mention that this device was not unique. There were many. We just have not found them yet. Now imagine holding a sword so sharp
and so strong that it can cut a falling silk scarf in half. That is not a fantasy. That is the documented performance of Damascus steel. And here is the mystery that metallurgists cannot fully solve. Between 300 BCE and 1700 CE, blacksmiths in the Middle East and India produced blades with a distinctive wavy pattern on the surface. But the pattern was not decorative. It was a side effect of an advanced manufacturing process that we only rediscovered in the 1980s. The steel was made from a raw material called woods, which came from India. The woods contained trace amounts of vanadium, molybdenum, and other rare elements. When the smiths heated and cooled the metal at very specific rates, those trace elements formed microscopic structures called carbon nanotubes and cementite nanowires. That is not a metaphor. Actual carbon nanotubes, the same material used in modern aerospace composites.
Think about this. A blacksmith 2,000 years ago, working with a charcoal forge and a hand hammer, accidentally or intentionally created a nanomaterial that modern laboratories struggle to produce consistently. The result was a blade that could bend 90 degrees without breaking, hold an edge that seemed to sharpen itself, and resist shattering in combat. When European crusaders saw Damascus swords cut through their own blades, they called it sorcery. But here is the real problem. The technique was lost around 1750. No one knows exactly why. Some say the raw ore ran out. Others believe the knowledge was held by a single family that died out. But the deeper mystery is this. How did ancient smiths understand thermal cycling and alloying well enough to create nanomaterials without microscopes or chemistry? And why have we not been able to fully replicate it? Modern metallurgists have tried everything: electric furnaces, computer modeling, exact chemical recreations. The best replicas still do not match the original. So here is the open question. Was Damascus steel a lucky accident, or evidence of a forgotten scientific tradition?
We are going to pause here and ask you something. Where are you watching from? Whether you are in Mumbai, New York, or a small village in Brazil, the next object changes how you see your own city. Because in 1936, during an excavation near Baghdad, the Austrian archaeologist Wilhelm Koenig found something that should have been buried in a 19th century factory. It was a clay jar, about 13 centimeters tall. Inside the jar was a copper cylinder. Inside the copper cylinder was an iron rod. The rod was insulated from the copper by a layer of asphalt. Do you see the problem? That is the exact design of a simple electrochemical cell, a battery. When Koenig published his findings, the scientific community laughed, until someone built a replica. They filled the jar with vinegar or grape juice, and the device produced half a volt of electricity. That is enough to electroplate silver onto a surface. The jar dates to around 250 BCE, the Parthian Empire, a civilization known for its gold and silver jewelry. So here is the engineering insight. To electroplate jewelry, you do not need to understand electron flow. You just need to know that a copper-iron cell in acid produces a current. And the Parthians clearly knew this because their jewelry shows microscopic layers of electroplated silver. But this is where it gets strange. If they had batteries, why is there no evidence of wires, light bulbs, or motors? Where is the rest of the technology? And that is the real mystery. The Baghdad battery may not have been a power source for machines. It may have been a medical device for pain relief or a ritual object for perceived divine energy. But the core contradiction remains. They understood electrochemistry over 2,000 years before Volta built his pile in 1800. So how did they figure it out? And what else did they use it for that has simply rotted away? The soil of a rock may still hold answers we have not found. Now we move from electricity to something even more surprising: concrete. But not just any concrete, Roman concrete. And here is the fact that makes modern civil engineers angry. The Pantheon in Rome has the largest unreinforced concrete dome in the world. It was built in 128 CE. It is still standing. Modern concrete, by contrast, has a lifespan of about 50 to 100 years before it begins to crack and crumble. We accept this as normal. But the Romans built seawalls, aqueducts, and harbors that have endured 2,000 years of waves, earthquakes, and salt water. So what did they know that we forgot? In 2017, a team led by geologist Marie Jackson from the University of Utah solved part of the mystery. Roman concrete used a mixture of volcanic ash, lime, and seawater. But the secret was in the chemical reaction. When seawater seeped into Roman concrete, it did not destroy it. It caused a rare mineral called aluminous tobermorite to crystallize inside the cracks. Think about this. The seawater actually healed the concrete. The crystals grew larger over time, filling voids and making the structure stronger. It is a self-healing material. And we only discovered this mechanism 2,000 years after they built the first harbor. Modern engineers are now trying to replicate Roman concrete for nuclear waste storage and seawalls. But there is a problem. The specific volcanic ash they used came from the Poizzoli region of Italy. That quarry is almost exhausted. So here is the open question. How did Roman builders, without chemistry or microscopes, discover the exact recipe for a self-healing, seawater-resistant, 2,000-year concrete? Was it trial and error over centuries? Or did they have a theoretical understanding of material science that we have lost? The answer is buried somewhere beneath the Mediterranean, and we have not found it yet.
But perhaps the most mysterious object on this list is not a tool or a weapon. It is a cup. A small, delicate, greenish cup that sits in the British Museum. It is called the Lycurgus cup, and it dates to 300 CE. From the outside, it looks like a beautiful but ordinary Roman artifact, until you shine a light through it. When light hits the cup from the front, it is green. When light passes through from behind, it turns blood red. For centuries, no one understood why. Then, in 1990, scientists examined the cup under an electron microscope. What they found changed everything. The glass contained millions of tiny particles of silver and gold. Each particle was about 50 nanometers in diameter. That is 1,000 times smaller than a grain of salt. At that scale, metals behave strangely. They scatter light in specific ways depending on the angle. The Romans had created a dichroic glass, a material that changes color based on lighting conditions. Here is the engineering impossibility. We did not understand nanoparticle optics until the 1970s. The Lycurgus cup was made in 300 CE. Modern scientists have tried to replicate it using atomic-level manufacturing techniques. The process requires grinding gold and silver down to precise nanometer sizes, suspending them in glass, and controlling the cooling rate exactly. It is painstaking work, even with lasers and electron beams. So how did a Roman glassmaker do it? The leading theory is that they ground gold and silver coins into fine dust, mixed it with molten glass, and got lucky with the cooling. But that is like saying a caveman accidentally built a car. The odds of randomly achieving the exact particle size needed for dichroic effects are astronomical. So here is the open question. Did the Romans understand nanotechnology at a conceptual level? And if they did, what other nanoscale wonders have we mistaken for ordinary rust and dust? The Lycurgus cup is not a cup. It is a message that says our ancestors were playing a much deeper game than we ever imagined. From glass, we go to optics. The Nimrod lens. Discovered by Austin Henry Layard in 1850 during excavations at the Assyrian palace of Nimrod in modern-day Iraq. It is a piece of rock crystal, oval shape, about 38 millimeters wide, and it is ground to a precise convex curve. That is a lens, a magnifying glass. It dates to 750 BCE. That is almost 3,000 years old. For decades, archaeologists dismissed it as a piece of decorative inlay. Then, someone held it over a text. The lens magnified the letters by 3 times. It works perfectly. And here is where it gets complicated. Assyrian artisans produced microscopic engravings on seals and jewelry. Engravings so small that the naked eye cannot see them. But with this lens, they become crystal clear. So the logical conclusion is that the Nimrod lens was a tool for precision engraving, a microscope of sorts.
But this creates a paradox. If they had magnifying lenses, why did it take another 2,000 years for someone to combine 2 lenses to make a compound microscope? Why did the telescope not appear until the 1600s? The answer may be that the lens was a closely guarded secret, a piece of proprietary knowledge held by a single guild of artisans. When the Assyrian Empire fell, the knowledge fell with it. And here is the question that keeps optical historians up at night. How did they grind a crystal lens to the exact mathematical curve required for magnification without understanding the geometry of refraction? The lens is not a random shape, it is precisely calculated. So either they understood Snell's law of refraction 1,500 years before Snell was born, or they had a method of trial and error that produced perfect results by blind luck. Neither explanation feels complete. The Nimrod lens sits in a drawer at the British Museum, and it is not talking.
We end our journey in China. The year is 132 CE, the Han Dynasty. An inventor, astronomer, and mathematician named Zhang Heng presents a device to the imperial court. It is a bronze urn, 2 meters in diameter. Around the outside are 8 dragon heads. Each dragon holds a bronze ball in its mouth. Below each dragon sits a frog with its mouth open. The device, Zhang explains, can detect earthquakes hundreds of kilometers away. The court officials are skeptical. Then, days later, a dragon drops a ball into a frog's mouth. No one in the capital felt a tremor, but messengers soon arrive with news of an earthquake 400 kilometers to the west. Zhang Heng had just built the world's first seismoscope. And here is the engineering insight. Inside the urn was a sentry pendulum. When the ground shook, the pendulum swung in the direction of the quake. That swing triggered a system of levers and catches that opened the mouth of the dragon facing that direction. The ball dropped, the frog caught it.
But this is the impossibility factor. Zhang Heng achieved this without a written theory of wave propagation, without calculus, without any understanding of seismic waves. He simply observed, experimented, and built. And his device was so sensitive that it detected earthquakes no human could feel. Modern engineers have built replicas. The pendulum and lever system works exactly as described. So here is the open question. Why did it take Europe another 1,700 years to invent the first practical seismoscope? Zhang Heng was not a wizard. He was an engineer. And his device proves that the path of technological progress is not a straight line. It is a branching tree. Some branches grow tall, others are cut down, and entire branches are lost in fires, invasions, and the simple passage of time.
So what do these 7 objects tell us? They tell us that the ancient world was not a dark age waiting for the light of modernity. It was a laboratory. Engineers in Greece, Rome, India, China, and Assyria were solving problems using the same human brain we have today.
The difference is not intelligence. The difference is documentation. When the Library of Alexandria burned, when the Assyrian palaces were sacked, when the Roman Empire collapsed, the knowledge was not passed down. It was shattered. And we have spent the last 500 years rediscovering what our ancestors already knew. The Antikythera mechanism, Damascus steel, the Baghdad battery, Roman concrete, the Lycurgus cup, the Nimrod lens, Zhang-Heng seismoscope. These are not anomalies. They are survivors. Fragments of a lost scientific tradition that we are only now beginning to piece back together. The real mystery is not how they built these objects. The real mystery is how much else we have already lost forever, and what we might still find, still buried, still waiting to be rediscovered. What do you think? Are we the most advanced civilization ever? Or are we just the latest in a long line of engineers who thought they were the first?